Okay, and we're going to be discussing what's involved in making matzah, what's involved in making chametz, and how does that work. We'll be looking at the halachic definitions of chametz and why it applies to some things and not others, based upon the best as we could figure out in terms of the biochemistry of it, the science of it. And here, oops, no, wrong thing. No. Wrong button already. Yeah, like that. Okay. Okay. Let us first start off with the basis for what we're going to be talking about. These are psukim which we just read this past Shabbos. Doesn't show up so well here on the screen. You could see it in your handouts a little better. I highlighted every time it says Matzah and Comets in the ear and Sa'ar. Where's the pointer here? We have here Matzah, referred to Matzah, then as Sa'ar, which means usually translated as sourdough. And then again Chametz, you can't eat Chametz, and you have to guard the matzahs. And then we have again another term of Machmetzes, which sounds like Chametz, and Sa'ar. So we see that the Torah tells us over and over again here that we have to eat matzah and we have to avoid eating chametz. Obviously they have something to do with each other, and our goal today is to find out how exactly that works. Wait, this is Parshas Bo, Yesh Matzah Grace. This was in Parshas HaChedesh, which we just read this past Shabbos. Wrong way, here we go. Now, read this from the bottom up. We have a pasuk here in the bottom which says Leisechel of Chametz Shivas Yom Teichel of Matzahs Lechem Oini, that you should not eat Chametz. This is referring to when we bring the Korban Pesach, and then you're supposed to eat, not supposed to eat Chametz with it, and 7 days you shall eat Matzah. The Gemara says based on this, that the way that why they chose this particular pasuk I'm not sure, but here we see that we're supposed to eat Matzah, not Chametz, implying that matzah is something which could be chametz, but isn't. Okay, this becomes important when we have something which cannot become chametz. For example, if you were to roast the kernels before you mill them into flour, it says then no longer can become chametz. If that's the case, you can't use that type of flour to make your matzah. So the Gemara says that matzah is something which it could be chametz, but you make sure to prevent it from becoming chametz. Things which cannot become chametz cannot be matzah. This will also be relevant as we proceed to discuss other kinds of cereal grains which are not subject to the rules of chametz and matzah, such as rice and corn and these things. They cannot become chametz, and therefore they cannot be used for matzah. Okay? Why can they not become chametz? That's what we're here to find out. Can you keep them? There's a special oath at the last page. You have to sworn to secrecy and confidentiality, everything else, and then you can keep it. Yeah. Okay. So their question is, what is chametz? And we said matzah is something which could become chametz. It's something which we prevent from becoming chametz. So we need to know how in fact we prevent it. And basically we know that chametz means leavened. If you look around, the definition of leavened is usually given as something which, bread which has had a leavening agent used in it, which is not very good as a definition because that's circular. You're defining leavened in terms of using leaven. Okay, fine, so what's leaven, right? That's supposed to do that. Leavened means something which has something cause the bread to rise. What causes bread or the dough to rise? And the answer to that is there are actually two major parts to the process. When you take flour and you mix it together, will it rise, won't it rise? It depends on two things. One cause of the rising is the fact that when the flour and water mix together, carbon dioxide bubbles form. And we'll find out why and how soon. They form within the dough, and that causes it to rise up. Another important part of the process is the fact that that the dough has gluten or forms gluten, which creates this strong, stretchy material which traps the bubbles. If you wouldn't have the gluten, so all the bubbles would just bubble out. Right? If you take something which is liquidy or whatever, and you have carbon dioxide in it, soda just fizzes out. It's the gluten which holds the dough together and traps the carbon dioxide bubbles, and therefore it just grows and grows and grows. Okay, I don't know if you can, on your handouts it got kind of small. Hopefully you can see it in the picture here a little better. Okay, why when you mix flour and water together do you get carbon dioxide of all things? Much better if you got like quarters and dollar bills. Why carbon dioxide? Okay, so most of the wheat kernel, we're going to talk primarily about wheat because that's typically what you use for matzah. Most of the wheat kernel is made up, 70% of it about is 60 to 70% is starch. We know about starch from giving our shirts into the cleaners. A more fancy name for starch is polysaccharides. Now, part of that word might look familiar. Actually, two parts of it might look familiar. Poly, I guess poly as in poly, many, right? Or poly one's a cracker. And saccharides, we're more familiar with that term from saccharin. Right, which saccharin has to do with sugars and sweeteners. So polysaccharides are things which have, as we could see like over there, is a molecule or a string actually of molecules together. So there's many of these things, these sweet things strung up in a long string. Basically there's a repeating pattern over and over and over again. And that's called, since it's a long string of many of these units, is called a polysaccharide. Okay, now what happens is one of the other components of the wheat kernel is a thing called beta amylase, which is an enzyme which is naturally found as part of the wheat. And this beta amylase does a very interesting thing. It chops up these long strings of polysaccharides into small sections in a very weird way. It cuts them into pieces of whatever you call them, two saccharides, two units. Two units. Okay. Right.
Each one is a glucose.
The one is right. In this case, it's a glucose. Right. We're getting there. I know. That's on the next screen, and you could just turn the page and see. I know. Okay. Now it's weird how it works. So it starts at the end of the string, and it counts by twos and breaks it every second one. So it breaks into units of two, which is called, logically enough, a duosaccharide, because it's got two of them. It is able to do this when there is water present. Okay, so when you take the flour and you mix it with the water, so then this enzyme, what it does is it takes, I'll show you exactly how it works here. It takes a water molecule, and everyone knows water is H2O, right? It's got two hydrogen atoms and one oxygen. And what it does is it breaks it at these points where there's this one oxygen molecule which is hooked to one on each side to two of these glucose particles. So it breaks it open, and now it has to replace the one that's broken. It's got to be replaced with another oxygen, which it drags from the water. But if you remember your high school chemistry, and the thing is that when I took chemistry in high school, I had absolutely no idea what I'm ever going to do with this. I could see algebra, geometry, even trigonometry comes to use at some time. And somewhere in the course of the 40-something years since then, I actually have had a few occasions where I've used geometry, and recently actually also used, I remember that if I wanted to find the sine of an angle, I had to go look up a table to find out the cosine, the SOHCAHTOA. I actually used the trigonometry or something, but I couldn't figure out what am I ever going to do with this chemistry. Learning this stuff and had absolutely no use for it at the time, and I'm surprised I remember any of it. But I remember that oxygen, the way I don't know, I have no idea what the contemporary terms for this are, because I'm sure they changed the way they call everything. But in those days, back then, oxygen at -2 meant that it could take 2 more electrons, and that's why H2O, H is a single one, so 2 H's, 2 hydrogens go to 1 oxygen. So if we have an oxygen there which is one receptor, accepting 1 electron from that unit to 1 from there, that covers 2. Now if we break it, so we have to stick something onto the end of that oxygen, which is the hydrogen over there, and now we have a loose end over there which the oxygen picks up, that oxygen and the other hydrogen. So the water molecule breaks up. 1 hydrogen goes to one side, and 1 oxygen and hydrogen goes to the other side of the break. And for some reason, our beta amylase does this. It could break it at every point. It doesn't. It breaks it every second one. It breaks them into disaccharides, which has a common name for also known as maltose. And you're familiar with the term maltose when you talk about malt for beer or barley malt, whatever. That's maltose. It's basically these funny kind of double glucose things. Now, here's the same picture all over again. What do you know? Bigger. Well, now you can really see it. Okay, so here you can see the HO is stuck at one end and the other hydrogen at the other end, and we've got from one long string of starch, we've got the fancy word for this is hydrolysis. That means simply using water to cut it up. Why keep things with the simple names when you can have complicated names, right? Okay. So now we're still just at this point all you have is we've broken the starch down into duosaccharides. You still can't do much with it. Yeah, it's pretty cool. So you have alpha amylase, which is another enzyme which is also naturally found in the wheat, which takes these doubles and it breaks them up into single glucose molecules. And the way it does it is exactly the same thing. It takes water, I wish this thing would stop, and again breaks open the remaining bond, and the water takes the atoms from the water molecules and sets. Okay, so now we've got glucose. Okay. We still don't have any carbon dioxide, which is what we're looking for, right? But have no fear, it's on the way. Okay, so far we've taken the flour, added water, and all that water does is provides the ability for these enzymes. It activates the enzymes and provides them with the ability to break up the molecules and break them down to glucose and to sugar. Now, the next step, really, different things could happen. We could either get water and carbon dioxide, or we can get ethanol and carbon dioxide. To get carbon dioxide, either way, the question is whether it's going to be water or it's going to be ethanol, alcohol. Okay, this already is done not by anything which is naturally present as part of the makeup of the wheat. This requires yeast. Yeast is something which is not naturally part of the kernel of wheat. Okay? But yeast is very readily available. It's out there floating around all over the place. There are yeasts which live inside of us. There's yeasts which live in our skin. There are yeasts floating around in the air. There's yeasts, different types of yeast sitting in all kinds of stuff. And the yeast it's a living thing, but it's asleep much of the time, sort of like Goldberg over there. Yeah, that's the Goldberg I meant. Okay, but when it gets doused in warm water, it wakes up. Oh, look out. Or coffee. Coffee is warm water. Okay. Now, what yeast does is yeast eats sugar. So So now, if you have yeast in your flour, it'll start working on the sugar. Until we've had the first two steps take place, there's nothing for the yeast to eat. It can't eat polysaccharides or disaccharides. It can deal with single glucose molecules. So it's got to convert it into sugar first, and then the yeast will start doing its thing. Now, where does the yeast come from? Most cases, most bakeries, or most bakers, most home bakers will actually put in yeast. You buy little packets of Red Star or Fleischmann yeast or whatever, and you mix it into your dough. You can just put your flour and water out there and wait for the yeast to find its way to your flour, which would probably work, but it would take longer. Most people who are baking are trying to wonder how long it's going to take and get things to the right consistency. You want to be predictable, so you don't want to wait. You want to put in yeast and find out, and you know how much you're putting in according to your recipe, and then you know exactly what to do. You know how long you have to let it rise, and so on. All the steps you're going to do. But there are people who actually, I guess, I don't know if they do this probably more as a hobby than as anything else. They like baking their own sourdough, and they like starting with their own yeast, which they capture themselves. They refer to wild yeast, which means yeast which you didn't buy in a packet, but you just pull out of the air someplace. Now you can. Some people actually will save some of their dough from once it's fully done. They save some of it and let it sit in the refrigerator because it's already got plenty of yeast in it, and they'll use that for the next time. But if you want, you can go on the internet and you can find out all kinds of different ways of starting your own starter, which is basically capturing your own yeast. And if you take care of it well, you feed it nicely, you give it water, you give it flour, you can actually grow your own yeast base, which in about a week you could have enough to really be in business for a long time. Most of the yeast which we have, that you buy commercial yeast, there's some started out that way a long, long time ago, and somebody, Mr. Fleischmann, I guess, or whatever, took some of this yeast and just cultivated it on some kind of medium and just keeps on growing more and more of the same yeast over and over and over again, which is nice because different yeasts work differently. So if you're always going to start off with wild yeast, you're not really sure about the properties of the yeast you caught this time, so you're not sure how long it's going to take to rise or whatever. That way they can breed it, they get consistency, they get it to do different things. You can breed it for how it's going to react to different temperatures, or all these kinds of things that you would like to know exactly what the predictability is. One of the things that bothered me when I was doing this was that if there is no yeast naturally in the wheat, that would mean that it's going to take a long time from when you mix your flour and your water until finally, a wind will blow in the right direction and some yeast is going to land in your dough, and it's going to one little microbe of yeast is going to land until it reproduces, until it starts making a difference. It's not going to take 18 minutes. It's going to take hours, days. Who knows how long it's going to take? So why are we so concerned about doing it within 18 minutes? It seems like it would take forever, weeks. Who knows how long it would take until you got any significant kind of rising based on wheat just landing there from no place. So one place I actually found that there are those who believe that although we said there are many, many kinds of yeast, the different kinds of yeast each find their place where they're comfortable. And so you'll have different species of yeast will live and make their homes in different places. It's like that there's yeast on the outside of grapes, which is why you can ferment wine out of grapes. It comes from again, it's a similar process of sugars and fermenting, which requires yeast too. Where does the wine get the yeast? It's there on the skin of the grapes. There are yeasts that like to live on grape skin. Apparently there are also yeasts which like to live in wheat flour. So from when you've ground your wheat into flour, it's been sitting around for a long time and had plenty of opportunity to actually pick up yeast along the way. Maybe nowadays less so because things are more sterile and they're packed in sealed packages. I don't know whether a sealed bag of flour now will have that much yeast in it. But apparently in days when things were left laying around more, probably was very common for yeast to have found its way into the flour long before you started baking. So therefore, it's ready to go when you need it. Okay, now, what happens here is one of two things. Again, we have fancy words for everything. The yeast now is going to eat the sugar, but what is it going to do to the sugar? It could either work with the oxygen that's available, either oxygen which is available, water has free oxygen dissolved in the water, or oxygen from the air, in which case it will produce one kind of result, or it can work on the sugar, eat it without using any oxygen, any free oxygen. And you wind up with different things. These two processes, by the way, is called respiration or fermentation. Respiration sounds like breathing. In fact, that's what it is, because it's using oxygen along with takes oxygen, pulls oxygen out of the air, wherever, in order to digest or break down the sugar. Or fermentation is where it breaks down the sugars without using oxygen. Okay, so first we have one representation here of what happens when it's fermentation, which is without oxygen, which has its name called anaerobic, meaning without air. But it sounds much more impressive in Latin. Okay, so now, in the first row, this long string of names over there, C12H12O2, that's sucrose. That's one of those molecules we saw before after it's been broken down. Then we have water. Then we have the working of the yeast over here. And you wind up with two of these kind of molecules. What?
6H12O6 is glucose.
Okay, fine. This here then goes through a second step. You take that, you mess around with it some more, and it produces ethanol and two carbon dioxides. Okay, so as the yeast works on it, it takes what we had, the glucose we had before, and it works its way through on it. And by the time it's finished beating it up, we wind up producing the carbon dioxide, which is going to help make our dough rise.
This is starting with sucrose. This is what's happening in flour with water.
No, this thing I picked up, this particular thing, you're right. It's starting with sucrose into glucose and glucose.
Making wine.
Right?
That's making
Okay.
wine. But if you're going to start
Right.
with maltose and glucose,
Right, to separate. Right.
it's just that
It's the second line.
line.
Exactly. Right. I cut and paste the whole two paragraphs out of someplace. You're right. Okay. Now, or you have the other possibility is what we have down here, which is just adding in oxygen, a bunch of free radical oxygen or things over there. So throw in a bunch of oxygen, and you wind up producing a bunch of water and carbon dioxide. Okay, so if there's oxygen available, the yeast will do this. If there's not oxygen available, it'll produce ethanol and carbon dioxide. Either way, it'll produce carbon dioxide. It might produce, now then you may wonder, well, if there's all this alcohol in your bread, why don't you get drunk when you eat bread?
It's a question the Muslims ask all the time because they're not allowed alcohol. It takes a lot of time for it to happen.
It takes the same amount of time as producing the carbon dioxide.
It bakes off.
Yeah, when baking, it evaporates. That's right. Okay, so what happens next here? Okay, now, so that's one part of it. We've produced our carbon dioxide, which is forming these tiny little carbon dioxide bubbles in our dough. Meantime, we said there's two things you have. You have also the gluten. Okay, gluten doesn't exist in the form of gluten in the kernel. It there are two other proteins which have gluten-like sounding names. I bet they were named that because they're precursors to gluten. And gluten comes from the Greek word for glue. Believe it or not. Which is also why gluons are called gluons. Right? Okay? So these two things, which I do not know how to pronounce, when they get wet, again, adding the water to the flour, the water does everything. Amazing. It's amazing thing, water. So the water causes these two proteins to interact, and they start forming the gluten. Kneading it and mixing it strengthens the bonds between the gluten. I had here a little thing from the internet, which I then decided was too silly, and I eliminated it because it was just sort of like a cartoon representation of how this works. But basically, they create the strands, which then form into a matrix. They lock into each other and they reinforce each other. So it gets stronger and stronger, and the kneading it helps that happen. Okay. So now we have our gluten, which gives a strong texture to the dough. It holds together. It's springy and elastic, so it doesn't just break open and let the carbon dioxide pop out. And the ethanol and the water, which were produced before, are trapped along with the carbon dioxide. They're all there inside the dough. Now, while you're baking, so what happens under heat, of course, is the water turns to steam. It expands. The carbon dioxide expands. The ethanol expands. And therefore, it rises even more. But then everything else evaporates out. So therefore, you wind up with your bread, which has all these little holes in it, because the gluten shaping the bread becomes hardened in the baking. Everything else leaves, and now you have your finished product. Okay, other things that happen also at the same time, mixing flour and water together, this helps explain why the bread rises. Meantime, there's something else. One of your scientists could tell me how to pronounce this word over here. It's probably protease, my guess. I was going to look it up, but I didn't. What? That's my guess. I don't know. It looks like protease, but that's probably it's two separate syllables breaking over there.
Enzyme which chews up protein.
Yes, right. So
it does to proteins what your amylase is due to starch.
Right. Anything that ends with the ASE is a kind of enzyme which eats up something. Right, because it eats proteins. Right. Exactly. That's why I assumed that's why I assumed that's what it's pronounced, but I did not look it up. Okay, so it's working on the proteins in the wheat flour, but something else is happening. And while everybody says that it's happening, I could not find simply laid out, like, little equations, step by step of what's happening. But the process of breaking down proteins produces all kinds of stuff. It's a complicated process also. It goes through many, many stages. And in the end, it winds up producing, again, I couldn't even find out whether it's ammonia or hydrogen sulfide. It's possible either one or both. I read a ton of stuff on why swamps are smelly and all this kind of stuff, trying to figure out what produces what. I could not get the specifics. Either way, this process is similar to the process of the breakdown of all organic material, which decomposing or decaying. That's what they all do. And very often it winds up being associated with an unpleasant odor as well. That is either because the hydrogen sulfide doesn't smell good, but hydrogen sulfide, it's not likely. Right, because that's the sulfury smell of hydrogen sulfide. Right, but it's not rotten eggs. Everything rots that way. We just associate it with eggs, because eggs have a lot of sulfur in them, so it's very strong. Or a lot of these things also they break up because there's it's ammonia, because there's what's in there that creates ammonia? The what? Nitrogen, which is there in the proteins, which is released in ammonia. Okay, now.
All of this is done by bacteria only.
the
Doesn't happen on-
protease.
Yeah, the protease is in the bacteria or the yeast. It's an internal, an
Okay,
organism.
since I could not find really hard information exactly, it was unclear in places as to whether, in the breakdown of these things, whether this is something external like the yeast, or whether there in fact are enzymes which are part of the wheat flour which themselves are triggered to do this, to eat up the proteins when the time is ripe. So I don't know. Some places it seemed to imply that it was actually part of the flour itself.
The production of ammonia is a cycle.
The ammonia is produced right.
Breakdown of
Right.
amino acids.
Right. But there's something which can or trigger it or whatever. But where do these things come from to begin with?
Where do yeast come from?
Okay, right. No. So the amylases are there. The yeasts come from external to the. Okay. So the proteases, I could not find out whether it's something which is external to the kernel or whether it's part of it.
Oh, there may be proteases, but they wouldn't form.
They wouldn't. They have to be activated. Right. They have to be activated to do it.
Proteases will form the amino acids.
Right.
They'll break down the protein to amino acids.
Right. Which and then.
Bacteria now will eat the amino acids and turn them into ammonia.
Right. All right. Exactly. So the question is, how many of these things are there in the wheat thing, and how many things are external? That I don't know. But there's enough of while one's preparing your dough and working that, this stuff is also happening at the same time, but it's not. It's sort of like drowned out by the. And this is a lesser process. I guess it's lower than the other process happening in the formation in the yeast at work, producing the carbon dioxide and the other the ethanol and the nice pleasant smell of the dough rising. So you don't normally notice it when you are baking bread, but it is taking place to some degree at the same time. That's important to see later. Now, just some more facts over here. That the pH level will make a difference. Apparently, a little bit of a lower pH will make most yeast work better. If perfect pH is 5.5, yeast will work down to pH of 4. And temperature, they give you different ranges: 90 degrees, 130, 100. It's about, general consensus seems to be that most yeast works best at about 100 degrees. You get above 130, 140, you kill the yeast. If it's too cold, below 70 or 80 degrees, it's dormant. You can freeze yeast without killing it, but it won't do anything. So these are sort of like and also if it's very acidic, it'll also prevent very acidic will also prevent the yeast from working. And now we've basically discussed much of the chemical processes. We could take off our white lab coats and let's just review first. Okay, the polysaccharides have to be broken down into sugar. Okay, once you have sugar, the yeast produces the carbon dioxide. The gluten traps the carbon dioxide, which causes the dough to rise. Okay, so now what will prevent the Comets? Obviously, water is integral to every step of the process that we saw. So if you keep the water off the flour, that's one thing you have to do. The other thing is, as we said, the temperature is significant. If you keep it below temperatures where these things can happen, it'll prevent rising. Keeping away other things which make it happen faster are things which can speed up the process. Kneading the dough forces out it rises because of the little pockets of carbon dioxide. When you beat down the dough, you force out the carbon dioxide bubbles so the dough remains flat. It doesn't rise. And then finally, when you bake it at high temperatures, you kill the yeast and you stop all the other chemical processes, and it won't become chametz. Okay? Now let's look at the halachos and see how this works out. Matzah is to be made from 5 species, which are generally listed as wheat, barley, rye, oats, and spelt. We are missing a comma there, maybe 2 commas. No, there are actually a little bit of question as to rye, oats, and spelt, as to whether those are proper translations of the terms which we find in halacha. Maybe they are, maybe they aren't. It doesn't really make much difference for our discussion here, since we didn't analyze the composition of each of these things. None of them really work as well as wheat in terms of making bread. And so matzah is made of flour, it's made of water. The halacha is you can't use other liquids instead of water, such as fruit juice or eggs. Okay? And then there are halachos, which we are given as to how to take care of the water to make sure that it produces matzah and not chametz. We have to use maim shel underwater, which is drawn the previous evening. It's done. The halacha is very specific. It has to be done just after sunset, before nightfall. We take the water from a well or a river. It has to be stored in a cool place overnight and at least 12 hours.
There's your source of bacteria from yeast.
The saliva.
No.
The water.
Water overnight is going to teem with organisms.
But where does it's covered.
It's in the water to begin with.
It's in the water to begin with. Oh, so before you draw it, it comes with it.
Letting it stand there, it's going to start multiplying. You're going to get lots of bacteria.
Because the water, okay, because the water is still
ready to add to your.
Okay, that's a problem. Okay, it's because it's standing still rather than left in the well.
Yeah.
Okay. Yeast lives in wells. All right. I don't know. Okay. Now, interesting halacha that if the water warms up, you can't use it. They don't give you a Shulchan Aruch. They didn't have yet the scales of Fahrenheit or centigrade, but it says it warms up to the temperature of saliva, it cannot be used, which I found that very interesting. Because obviously your saliva fresh coming out of a person is approximately a person's body temperature, which is approximately the optimal temperature for the yeast to work. Right? If it's 100 degrees about is the optimal temperature, and the saliva is approximately 98.6 or whatever, you're judging this by the touch. It means you're at the temperature where your yeast is at its optimal. Okay, the halachos, the flour obviously has to be guarded from the time of harvest or from the time of shmura matzah. The pasuk says you're supposed to guard it. You saw at the very beginning, you're supposed to guard the matzahs, guarding them from becoming chametz, and so whether it's from the time of harvest or from the time when you begin to mix it with the flour or from the grinding, different opinions as to when it is, but you have to watch it to make sure that it doesn't come in contact with anything. Watching it means not standing there and stirring it 24 hours a day. It means making sure that it stays dry, basically. Once it's ground up into flour, you have to let it, you cannot use it for 24 hours. The purpose of this halacha is simply to give the flour the opportunity to cool down. Grinding is a process of friction. It heats up the flour, and we're trying to keep things cool in order to prevent it from becoming chametz. Okay, these we saw before. Things heat up to a certain point, makes things become chametz more rapidly. You have to avoid that. Also, while making it, halachos are, went too fast. You have to keep it out of direct light of the sun. Obviously, sun shining on it is going to warm it up. You have to work it. If you leave it lying without working it, so you're not squeezing out the carbon dioxide, it gives it a chance to rise. And it also has to bake in 18 minutes. Obviously, these processes which we described before take time. We said we have at least 3 different processes we have to go through. You have to break down the polysaccharides and the disaccharides, and then the glucose has to be converted into carbon dioxide. It takes time. How long does it take time? I imagine under normal circumstances to go through the steps, and under optimal circumstances with yeast present and everything, to the point that you get some appreciable, discernible results. I read some places somewhere in the neighborhood of 20 minutes. So the halachic share of 18 minutes, more or less, is based upon that. Okay, the Mishnah Gemara mentioned that you can tell that it's become chametz if you see these signs. If it's expanding, obviously. If it turns white, if it forms little cracks in the surface, and if when you bang it, it sounds hollow. These things all come as a result of the process which we saw before. As it goes through the fermentation or respiration, and the dough stretches. So that'll cause it to expand, turn white. It'll sound hollow because of, in fact, is hollow. There are all these little carbon dioxide pockets inside it. All right. Now, so these things all work when we talk about those things which can become chametz. Those things which cannot become chametz, such as corn, rice, soy, potato flour, they do not, one of the elements you said was they have to be able to form gluten. They do not form gluten. They don't have the proteins which make gluten. So you're not going to get that part of it. Additionally, corn does not have the alpha amylase. That's what breaks down the duosaccharides into the glucose. But it's not present in corn. Rice has neither of the amylases. So rice it still has the long strings of polysaccharides which don't go anywhere. But the protease activity, which is breaking it down into whatever, leaving ammonia and so on, that will happen. Okay, and the Gemara therefore says that these other things, although they seem to ferment in a way, if you add them to water, something happens, there's things going on. The Gemara says that's not called chametz or chimutz, that's called sirchain. Which looks like a play on words. The Gemara says, well, why can't you do other things? They seem to have a similar process. The Gemara says, nah, that doesn't count. That's sirchain. What does it mean in sirchain? Sirchain really means decomposing, and also right, sircha means something which is rotted, right? It means to rot. Okay, why? Because this activity, which has that rotten smell to it, happens or can happen when these other things. It's not chimutz, yeah.
But if it doesn't have gluten, then it shouldn't be able to rise.
It won't rise very well in any case, but something happens. You know, it transforms. Just like flour and water, it doesn't just sit there. Things go on, right, and turns into something else. So there is things happening, but that thing which is happening is a totally different process. Therefore, it's not called chametz. Now, how do you make cornbread then? Right, we've all heard of cornbread. How do they get it to rise? Oh, well, how will a leveling agent help if it's not capable of going through these processes?
There's enough of
well, the gluten part, yeah, it'll manage, right? But it doesn't. But if it doesn't have a natural leavening agent, so what does the leavening agent do? The leavening agent basically, they put in two chemicals, which when they combine with water, they produce carbon dioxide. So it's not creating carbon dioxide out of the starch of the grain. They put in baking powder. Baking powder basically is whatever, I forgot, bicarbonated soda or something, and you mix it with water, and it starts to. You could put it on the table and put some water in it, and it starts bubbling. It's producing carbon dioxide. So when you mix it into your cornmeal, it produces carbon dioxide inside your cornmeal. But it's a process which is happening independent of the meal. What? Right.
Sodium bicarbonate.
Right. So you just mix some of that into that's what they're doing when they make these other things, making the breads. You're mixing in baking powder or baking soda. Also what they call quick rise breads. They just, instead of waiting for the bread to interact, or the wheat to interact and rise, you just put the quick rise breads are made with baking powder where the carbon dioxide is produced separately and just it's like injecting it into there, as opposed to chametz is where we're making producing the carbon dioxide directly out of the starch of the wheat itself. Some of the things I found interesting as I was doing this research, a lot of these things seem to be contradictory. So when you do like scientific research and you come up with results and evidence, you don't necessarily know what's going to happen as a result, because they could be true, but there could be other truths which sort of counterbalance that. So for example, kneading, as we saw, forces out the carbon dioxide and prevents chametz, but kneading also builds up and strengthens the gluten. So this requires a judgment call to determine that you have to knead the dough constantly, because the squeezing out the carbon dioxide is more effective in preventing chametz than the fact that it also is strengthening the gluten, which helps create the chametz. right? So it's someone that determination had to be made. Or low pH will prevent amylase action and also weakens the gluten, which is one of the reasons why you can't use fruit juice to make matzah, because it will not. It has to be something which could become chametz. Flour and water can become chametz, so we make matzah. Matzah is defined something which could be chametz but isn't. But fruit juice and chametz, being that it's very acidic, low pH, the amylase won't work, the gluten won't work so well, so it's an anti-chametz agent. But it can increase yeast activity, which means that if you put it in after you've gone through the first stages, or you don't put in enough of it to kill the first stages, so then it'll actually make it enhance the rise. That's some recipes actually have you putting in a tablespoon of vinegar into your dough, because the acid and the low pH actually enhances the yeast. Again, it can work both ways. Is acid good or bad for your comets? It depends. Salt also works both ways. And this is really interesting. Salt slows the yeast activity, which is anti-chametz, but this was presented one place as being positive for your bread rising, because if the gas is produced too rapidly, it breaks its way through the gluten. So if you slow it down, the gluten isn't broken, it keeps the gluten intact, so then it rises better. Salt also prevents yeast from producing enzymes that damage the gluten. So that again enhances the gluten. So salt can work both ways. Halachically speaking, if you use salt water to make your matzah, it would could become chametz, and technically it would be, I guess if you worked it very carefully, we don't make sure not to put salt in, because we don't want to mess around with the process, because we don't know which way it's going to go. But okay, that is basically the story of what makes chametz. We ran through a number of the halachos rather quickly there, but those are, you can look it up in Kitnius. They have a section there on how to bake matzah, and it gives you all of those halachos there over a couple of pages. And now you go back, you can see how each one of these halachos relate directly to these chemical processes which take place, which are unique to basically to wheat and those similar things. The other things, the spelt and rye, whatever, they're basically part of the wheat family. If you look at the Latin names, a lot of these things, they're called triticale something or other, which is Latin for wheat, and they all have just different second names. So it's all part of the same family. They have a similar structure, and they all more or less work the same way to some degree or another. So that is the story of how to make chametz, how to make matzah, and how a lot of these oddities of the halachos all work very well to ensure that we enhance that we're dealing with things which are capable of going through all the processes of becoming chametz, but on the other hand, we make sure to deal with it in such a way from preventing them from taking place, and wind up with a finished product of baked matzah that can be used for Pesach.
The water that we're using today
Yeah.
has to be from a well or from a river.
Mm-hmm.
Is it sterilized?
No.
It's just natural water. It's got billions of organisms. Billions.
Yeah, sure. There's plenty of organisms, right?
So those are what are turning things hot. The
There-
rest of it, if you start with sterile distilled water
Mhm.
and flour, you could probably wait 30, 40 minutes.
You
and
probably,
it would never turn
right.
hot.
And again, you have to sterilize your hands or whatever, all the surfaces that come in contact with it. It's true.
Exactly.
Right. That was, by the way, I ran it through a little quickly. That was one of the, I think it was mentioned, the evidence that there must be yeast there in the flour was because if people sterilized their flour before they tried starting their sourdough batches, it never got anywhere. If the yeast was coming out of the air, it wouldn't make a difference if the flour was sterilized.
Let's go back to
Okay.
the shrine.
Okay. They did not they weren't sterile.
They didn't have Fleischmann's yeast.
Right.
Okay. Everything was sourdough.
Right.
All of the containers that they made their bread in
Mm-hmm.
were all contaminated.
Oh, for sure. Right.
So if they were going to make a matzah in the same containers,
Well,
they would immediately contaminate the whole thing.
oh, for sure. Well, the matzah that they made that came out of matzah, okay, well, it's a whole other discussion. The matzah which they had in Mitzrayim, they had two types of matzah. There was matzah which they made carefully, quickly to prevent it from becoming Comets, where they were told that be'erev teichlu matzah, they have to eat it with they have to eat it with matzah, which was made. And then you have the matzah which they took out with Mitzrayim, which did not rise, not because they planned it that way, because because they were in a rush out of Mitzrayim and didn't have a chance to rise. So there, that's just the way it happened. When we go about making matzah, so we're taking things which have the potential for all the reasons which you listed more of becoming chametz, but we do it in a way of preventing it from actually becoming chametz. And apparently, all the concern about 18 minutes, and they're busy in the bakeries and changing everything every less than 18 minutes, washing their hands every 18 minutes, replacing all the utensils and so on and so forth, is not to say that within 18 minutes it definitely will become chametz, because there's a lot of things that have to happen. The possibility of becoming chametz exists once you've had 18 minutes of that's the minimal time it would take for it to become chametz in optimal conditions. If you've got all your yeast and your microorganisms all ready to go, and you have your flour and your water and the right temperature, everything works right, you'll get there within 18 minutes. If you start adding in significant amounts of other things, it can go faster. If you raise the temperature a little bit more, if you mess around with the pH a little bit more, you actually probably can speed it up a little bit. But that idea of 18 minutes is under normal circumstances, doing, where you've, have normal ambient temperatures and normal, cool water and flour, and not deliberately putting anything else into the mix. It would take 18 minutes.
Now the ladies who are here
Yeah.
made bread.
Yeah.
They know that once you've added the water, it is done immediately.
Yeah.
The way you form gluten
Mm-hmm.